In this video, I want to talk about the hybridization in organic chemistry. So I want to look at the concept of hybridization in organic chemistry. Then I want to look at the sp3 hybridization, what it means so you understand the sp2 hybridization and the sp hybridization and the various characteristics. Then after that, I want to look at some key exam questions. I want to see in the exam. So what you really want to do is to what stick to the end of this video and take down every single thing. Let's get started. Hybridization in chemistry is the process of mixing different atomic orbitals to form a new orbitals. The hybridization process occurs when the atoms in a molecule come together and form chemical bonds. These bonds are formed by the sharing or exchanging of electrons between the atoms. These there are several types. There are several types of hybridization, such as the sp3, the sp2, and the sp hybridization. Each type results in a different arrangement of electrons and a different shape of the molecule. Hybridization plays a crucial role in many chemical reactions, and understanding it is essential for predicting the behavior of molecules and designing new compounds. So that is what the key concept you need to understand when it comes to what hybridization. So we're talking about organic chemistry. So we're talking about uh, mixing of what two atomic orbital to form a molecular orbital. For example, here, let me explain to you. So for example, here we have hydrogen, right? So here we have one x1, another hydrogen, one x one. Yes. So when you add them together, remember covalent bond means what? The sharing of what of the electron, right? Here is the atomic orbital. Here is what is the atomic orbital. So when you mix them together, you are going to form something like this. Do you get that? So here is going to be what? A molecular what orbital. So when this is formed, I want to have so this bond is what is holding them together. Do you get that? So this is called a covalent bond. So hybridization is when you mix two atomic orbitals to form a molecular what? Orbital. And a bond is formed between two of them. So this bond there contains two bonding electrons. You get? So that is it about the hybridization process. So we have to look at the different type as we move on. So let's look at the sp3 hybridization. In the sp3 hybridization, carbon combine one of the two x orbital with three of what two p orbital. That would make what the sp3. I know that you may not understand this stuff very well, but now let me explain to you. Carbon have what we call the ground state configuration. We also have what we call the what the excited state configuration. For example, here, when our carbon is what is 6, right? So the electric configuration is 6. So when you want to write the electric configuration, here we have 1x2, 2x2, and what 2p what 2. Do you get that? So yeah, the valence electron is 4. The valence electron is what is 4. If you should write the orbital diagram, we would have according to On's rule, electron must spin up before spinning down, right? So these two eggs, this is the orbital diagram because I've got two electrons. You get that? Then for the p, remember p is having three suborbitals, which what? 2px, 2py, what? 2p what z. So this one is having 1, 2. So this is called the ground state configuration. Do you get that? So in the ground state configuration, Carbon is having just unpaired electron, two unpaired electrons, then what? One empty orbital here. Then it's having what? A paired electron here. Normally, carbon do not use the ground state configuration in bonding because it only have two unpaired electrons. So we have we call the excited state of carbon. In the excited state of carbon, because there is an empty uh, p orbital here, electron, this paired electron will be promoted to this empty one. So what you want to have is this one here. So we have one, two, three, four. So it's called the excited what state. So this is what the key concept to understand what the sp3, the sp2, and what the sp. So in the excited state of carbon, because one electron is wanted from here to here, now have what? Four unpaired electrons. So here we have 2x, 2px, 2py, what? 2p what z. So this is what carbon make use in bond what formation. So in the sp3 hybridization, what it means is that carbon make use of the 2s and all the what 2p in bond formation. So remember I told you that hybridization is the mixing of two atomic orbital to form molecular what orbital. What means that carbon can bond with this, bond with this, bond with this, bond with this. So when you have something like this here, now in the sp3 hybridization, what it means that carbon need more four electron to obtain the octet. You get carbon needs what? More four electron to what? To obtain the octet. So you need to bond with this guy, bond with this one here, bond with this, and bond with this. So if it should bond with four hydrogen, four hydrogen. So if one hydrogen come here and bond with it, it have make it of the of what? Bonding. If other hydrogen should come and bond with this, what do you understand? That what? Bond with this. So if other hydrogen should come and bond with this, it have make use of this one. If other hydrogen should come and what bond with this, I will make use of this bonding. So the mixing of what? Two two or more atomic orbital, you go to form a what? A molecular what? Orbital. So in the sp3 hybridization, what you need to understand is that carbon make your use of what? The 2x and all of the what? 2p in bond formation. So that would now result to what? X, P, P, and P. So all the what four valence electrons are used in bond what formation. Sorry, all the four valence electrons are what use in bond formation. So that's why it's called sp3. So this one here is a methane. Do you get that? It's a methane. And all these single bonds are called sigma bonds. Sigma bonds are strong bonds. Do you get that? They are what strong bond. They are formed as a result. Carbon make use of the what unpaired electron or the valence electron for bond what formation. So they are called sigma bonds. Do you understand? And there are some key stuff you need to understand when it comes to what the what sp3 hybridization. Because these are stuff you're going to see in your exam. Carbon, now sp3 hybrid orbital are saturated hybrid orbital because all the four valence electrons of carbon are used in bond formation. So the sp3 hybridization are called saturated and they form sigma bonds. So example is what is the alkanes like the methane, the ethane, the propane, the butane, and the rest. To get that. Another thing is that now sp3 can explain the tetrahedral structure of a molecule. So sp3 hybrid orbitals have what the tetrahedral structure in the molecule. So this is what you want to put in mind. You get, because all the four valence electrons are used bond formation. So the shape of hybrid orbitals is what the tetrahedral structure. Another key note you really want to take note is that now they explain the bond angle of what 109.5 degree. So the bond angle in sp3 is what 109.5 degree. So you want to what, so it means that they are oriented in that what angle. Another thing you want to take note is that what now sp3 contain 25% s character and what 75% p character. So how do you get this one here? Remember, in the sp3 uses what four fits, right? X, px, py, what pz, right? This everything what make up to be what 100 what percent. You got everything what make up to be what 100%. And because everything make up to be 100%, now how many of it do you have here? One, two, three, four. If you divide by four, then you have 25% each. So S character is just one. So your S character equals what? 20 what? 5 what percent. P character is what? Now remember here we have P. Each of them have what? 25, 25. So P is made up of what? PX, PY, what? PZ. So when you look at it, you got to be what? 75 what percent. Look at 70 what? 5%. So that is what the P character. So in the sp3 hybridization, now it contains SP, no S is what 25% character, and what P is what 75% character. You really want to put this down because these are stuff you really want to see. These are stuff you see in your what exam. So that is it. So let's look at what the SP. Let's look at the sp2 hybridization. Now, in the sp2 hybridization, carbon make use of what? The carbon make use of the 2x and 2 of the what 2p orbital for bonding, leaving one of the p on bonds. So the remaining one will now go to what bond to what under carbon atom to form. You go to bond to under what unpaired electron of under carbon atom to form a what a second bond. I want to explain this to you. This and this. So here we have one, two, three, four. Right? Now, here we have the 2x, here we have 2px, 2py, what? 2p what? Z. So you have to make use of this. I want to make use of two carbon. So you can use one here. So make use of what? 2. 2x, 2px, 2py, what? 2p what? Z. So just like carbon here, one, two, three, four. One, two, three, four. So when we talk about the sp2, as the word implies, S, P, and what P, it means that all the four valence electrons of carbon are not used. Now they only make use of what? The X, the what P and P. One is not used. The same thing with this other one here. You get, so when you combine two of them together, therefore two of them combine together to form this one here. So it means that this guy have combined with this carbon here to form a bond. Remember, here we have, so let have here is with X and X that bond together. It means that carbon have used this one, which is this one here. Carbon have used this one. Yet, so this one is now used to get that. Now, if you focus on this other one here, carbon can make use of what 2p. So this carbon will make use of this 2p. This carbon will make use of this 2p. So now carbon can bond with what another hydrogen here, right? Which is this one here. And carbon what bond with another hydrogen, which is this guy. But leaving this one on bond, so you didn't touch it. Similar thing here, carbon will bond this other carbon what bond with hydrogen, right? And bond with another hydrogen here. You got leaving this. So what this means that a carbon connected to this carbon here, then this one having what, two hydrogen, they have what, two hydrogen. So here we have this one here. You get, so these two are not used in bonding in the what, sp2. This is what we call the sp2. But here's the problem here: carbon is not having the octets. Do you get? Carbon is not having the octet electron. Remember, in the octet, carbon must have 8 bonds. So carbon must have 8 electrons. I can either be for what? For you can call what, 4 bonds. If you look at it here, we have two, 3 bonds. One, two, three. Then uh then unpaired electron here. This is that. So 3 bonds, one, two, three, and unpaired electron at this point. So what do you mean? That here I have 6 electrons plus one, making it 7. Same to this one here. So but carbon want to contain 8 electrons. So what this two does is that because they are not used in bonding, this one is not used, so it's not being used in bonding. They're now going to form a temporary bond. That temporary bond now will now result to what, a second bond. So when these two combine, they now result to what, to a double bond here. So let me write it again. To what? To a double bond here. So that second bond that results as a result, or that form as a result of what? The two unpaired electrons of the two carbons are not used in bond. They come together to form a temporary bond. So this temporary bond is called the pi bond. Why this one is called sigma what bond? So in the sense that in the sp3 hybrid, in the sp2 hybrid carbon, it means that carbon form a double bond between two carbons. Do you get that? So a double bond is formed between what, two carbons, which are what, a pi bond and a what, a sigma bond. So this is really one. This is what you really want to what, put in your mind when it comes to what, sp2. Do you get that? Which is this? So now in the sp2 hybridization, carbon make use of what, one of the X and what, two of the P in bond formation. Therefore, they are called unsaturated hybrid orbitals. Now, because not all the four valence electron of not all the four valence electron of carbon are used. It is for what, it is called unsaturated hybrid orbital. Remember in alkane, so remember in the sp3, now carbon makes use of everything in bonding, right? So that's why they're called saturated. But in this one here, carbon make use of just out of the four, carbon make use of what? Three of it, leaving one to form a second bond that result to what? To the pi bond. That's why it's called saturated. So this is what you want to know. An example of compound that contain double bond are the what? Are the alkenes and the carbonyl. So like the ketones and the aldehyde. So this is what you really want to pay close attention. So what are the key things you need to what know when it comes to what, the sp3, sorry, the sp2 hybridization? One, which I've said is what, they make it of what, just three of what, four valence electrons for bond. So they are called unsaturated hybrid orbital. The next one I want to look at is what, the sp2 can explain the what, trigonal planar in a molecule. So in the sense that the shape of the sp2 or compound that contain sp2 are called trigonal what, planar. You want to pay close attention to that because you see it in the exam. Another thing you want to take note of is it can explain what, the bond angle of what, 120. So 120 what degree. So the bond angle what in sp2 are what, is are what, 120 degree. Just like when you have something like this. Do that. So the bond angle is what? 120 degree. Another thing you want to pay close attention is that it contains one sigma bond and one pi bond. So whenever I see a double bond, it always contains a sigma bond and a pi bond because a question can be given to you that how many sigma bonds do you have here? How many pi bonds do you have here? In the case we're going to see later in this video. Next, you want to look at is what is the what S and P character. Now, the sp2 contain 33% S character and what 67% P character. You want to put this in mind because it may ask you which of the hybrid orbitals contains 33% S character or contain 67% P character. It's called what the sp2 hybrid what orbital. So these are stuff you really want to put in mind in what in sp2 hybridization. Let's move to the next one. Let's talk about the sp hybridization. Now, in the sp hybridization, as the word imply, S and what and P, carbon make use of two valence electron for bonding out of the four valence electron. How about so we have 2x, 2px, 2py, what 2p what z. You have 2x, 2px, 2py, what 2p what z. So when you look at this one here, remember here we have 1, 2, 3, 4. 1, 2, 3, 4. Right? So here we have this one. 1, 2, 3, 4. 1, 2, 3, 4. Do you get that? So here, therefore, two of them will bond together. So it means that carbon have used this guy and carbon have used this one here. So because I talk about the SP. Now, out of the three, out of the three P, only one is used. So carbon will use this one, like this guy, and carbon will use this one here, like this one. So this remaining two are not used. Here are not used. Here are not used. Remember, no matter what you do, carbon really want to form four bonds. You get each to complete the octet. So how do you achieve this? Because there's not sufficient amount of hydrogen. This only have one, this only have one. What happen here? These two will what bond together to form a temporary bond. Why so come together to form a temporary bond? Yet, so so now result to what to a triple bond. What you see here is this. This is that. So this is now what is second, and this now result to what to a triple bond. So what you want to put in your mind is that in the sp hybridized orbital, it means that in the sp hybridized orbital, carbon use just two of the valence electron in bonding. So the remaining two will now result to a double bond and a triple bond. You get so it means that in a double bond contain two pi bonds and what one sigma bond. So whenever you see a triple bond, what you want to put in your mind is that that triple bond contain one sigma bond and what two pi bonds. The pi bonds are what are called temporary bonds. So any can easily what break it. You get that? So in the sp hybridization, carbon makes of what the two eggs are what one of what 2p for bonding. The remaining ones are what are not used. The keynote. The keynote here is that carbon make use of uh, two L's and what one of what 2p for bonding. Therefore, they are called unsaturated compound. Example of this one is what is they are what the alkynes are what nitrites. Alkynes are what nitrites. Both of them contain a triple bond. Now, the next one to look at is that they contains now, sp contain two pi bond and what one sigma bond. Next one to understand is that they have what a linear shape. So uh, whenever I see sp, they always have what a linear shape. You want to put that in your mind. And the bond angle is what 180. All linear shape have the bond angle of what 180. They contain 50% S character and 50% P character. The S and the P character are used in what bond characteristics, like the bond length, the bond angle, and some other stuff. You want to pay close attention to, like the polarity of the bond. You get so these are stuff you want to what pay close attention when it comes to what the sp hybridization. So we have done the SP3, SP2, and what SP, and there are what various keynotes. You will have to what go back to this video again, take down this key notes. So let's see some questions you see in your exam. So let's look at this question here. If they ask you how many sigma bonds are here and how many pi bonds are here, so these are the type of question you see in your exam. So what I want you to do here is to what get the numbers of what sigma bond and get what numbers of what pi bond. They also ask you what hybridization can you see here. So I'm going to watch give you the different way you can see question. Now, here they can say here is A, here A, carbon B, and what carbon what C. So they will ask you what hybridization occur in what various carbon. See what A, B, and what and C. A, B, and C. Now, carbon A, we look at carbon A. Carbon A have this all single bond. Do you get that? So when the carbon have a single bond, it's called the sp3. So this carbon is what sp what 3 sp3. Do you get that? Sp3. Now B contain a double bond. Do you get that? B contain a double bond. So now whenever a carbon contain one double bond, it's called sp2. So carbon B is what? The second carbon is what? sp2. Now, what about C? C contain a triple bond. And when I say a triple bond is what? sp. Now, they may also go further to ask you what is what bond angle. Now, the bond angle here is what 109.5 degree. Here is what 120 degree. And here is what 180 what degree. So if they should ask now what is the shape? This is called tetrahedral. Tetrahedral structure. Tetrahedral structure. This is called trigonal. Trigonal planar. Trigonal what? Planar. Why is it called linear? This is that. So these are the key stuff you may ask. So how many pi bonds do we have here? How many sigma bonds do we have here? Remember, a double bond contain one sigma bond and what? One pi bond. Right? Then a triple bond contains what? Two pi bonds and what? One sigma what bond. So here you can say numbers of what? Pi bonds. So here we have a double bond. A double bond contains one pi bond, right? A triple bond contains what? Two pi bonds. So 1 plus 2 here going to be what? 3 pi bonds. 3 what? Pi bonds. Then if you look at the sigma bond here we have 1, 2, 3, 4, 5. Remember, whenever I see a double bond, it contains what? One sigma bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one here contains numbers of what? Sigma bonds. Because of what? 9 sigma what? Bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sigma bonds. Sorry, make a mistake. 10 sigma bonds. So when you're calculating what numbers of pi bond and sigma bond, you know what to be extremely careful so that you are not going to what make mistake. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sigma bonds. All this video is helpful. This will be a long video, and I believe you have understood so many things in this video. So these are stuff you really want to use in these are stuff you really want to understand when it comes to what hybridization. What type of hybridization exists in what? Propylene, propine. Sorry, what you just ask you, what type of hybridization occur in what? In propine, propine. So what you want to do here is what you want to do here is to draw the structure, propine. Draw the what? Structure of what? One, two, and three. Right? So propine is having a what? A triple bond. So you have this, you have this, and this. So this carbon here is already having a triple bond and what? One hydrogen. Just have what? A single bond. So these two carbon are what? Sp and what? Sp. And here is what? Sp3. So the hybridization that occur here is are what? Sp3 and what? Sp. Look at that. That is it. So how many pi bond? We only have what? Two pi bonds. Right? How many sigma bond? Here we have one, two, three, four, five, six. Six sigma bond. So if this video is helpful, I believe you have enjoyed this video. Please subscribe and like, then share to your various friends so that they can also what, take part of what of this class. You get, so you can leave your comments at the comment section. I will respond to that. Thanks for watching. So we also have videos on nomenclature of the organic compound. You can go check one of it out if you wish to. Thanks for watching.